Kitty from Software Engineering. I'm going to today to present my project. It's about a fire and security alarm monitoring system. The big idea for this project to monitor a lot of alarms in different locations and send the just in case of fire and security alarm. Sorry for that. And in the case of fire or security situation, the monitoring send alarm or send a message to the emergency service. Then the emergency services receive this alarm, these messages, and send it to the fire station or the police local station. This is the entity relationship diagram for this system. We have emergency services. It has first name and last name and ID. It will be unique and date for receiving and sending alarm messages, and time and cell phone number and email. This is the attribute, and it sends and receives many messages from the monitor. It has the ID and first name, and each monitor should be monitors multi-alarms in different locations. The system boundary in this project, we have, I suppose, I have two buildings. Each building has many alarms, and the monitor man monitoring all these alarms and send it to the emergency service, which will be outside this building. This is the data flow diagram. Monitoring input password. Then when you get accept for password, will get in the system. Then check alarms. If it has any intruder or if it has any fire situation, send it to the emergency services. I'm going to use two architecture styles: object-oriented style and client-server style. The first architecture, object-oriented style, this is what we have. We will see. This is the level 1 component diagram, and this is the level 2 component diagram. We have a graphical user interface component, and the connector will be procedure calls, and monitoring zone P and zone A, its component, and we have alarms and emergency services and fire station and police station. These are components. This is the class diagram for object-oriented for the first architecture. We have the first class. It's a graphical user interface. We have user name and password, and also alarms and monitors and monitor and emergency services. This is the mapping. Each one, the graphical user interface has the same name, graphical user interface in the class diagram. Alarms has the same names. And as you see here, the connectors will be procedure calls. The second architecture is client-server style. This is the level 2 component. The same components we have in the first architecture as also we have in this architecture. It's fire station, police station, emergency services, and graphical user interface for the monitor and two zones. And this is the server side, and this is the client side. This is the class diagram for client-server architecture. We have alarm, sends alarm to the monitor, and this monitor will send to the emergency service. Emergency service will send, if in fire case, will send it message to the local fire station. If it's in intruder case, will send it to police local station. This is the mapping for components. We have here two connectors, procedure calls and HTTP request. That's the different from the first architecture. And the advantage and disadvantage of these architectures, as we see here, Object-oriented style, it's understandable because mapping the application to the real project, and reusable and maintainable because it's easy to maintain each project separately. But the disadvantages due to the large code or the large instruction we use, it has larger program size and it's complexly and slower performance. All these reasons for the large lines of code that causes these problems. And the other side, the client-server style, we have the advantages. It's understandable, like object-oriented and reusable. Integrity because access each information without needing to their from different location, without needing to their platform or to their specific hardware. And security by using control access for each client can get to the system. It's using a good control accessing. The disadvantages, overload services. If we have a lot of sending and receiving messages, it will get overload services and it's costly. The reason to choose client-server style to implement my project, the fire and security alarm monitoring system needs to send and receive data from different locations, from monitor, emergency services, police station, fire station, and also this project needs to have security. Only the authorized people can turn on or off the alarms. Also, this program needs to be integrity. Monitor, emergency service, policeman, and fireman need to access to the information that is resident on the network but their platform without needing to log in terminal or other processor. This is the virtual Windows that I decided to implement. This is the login window by using username and password. Then you will get to this window. You can see as you see the table, all alarms, and you can see the status of this alarms if in or off, and locations, which building, which floor, and which room, and battery. You can see also the battery of these alarms. Here we have 3 buttons: edit the alarms, or send it to emergency services, or exit. Here, when you get to the edit alarms, you can just choose the name of this alarm and change the status, and then save the status of these alarms. Here, these 3 windows are parallel functions in this system. The monitoring system should monitor all alarms in parallel in the same time. This is the real system. I wish to show you in the live right now, but I couldn't. Sorry for that. This is the real system that I implement. This is the first page, which is you have to choose if you have account login or create a new account. When you register for this site, just write your name and password and this register. This is the second window. The third window, the login account, the same thing. This is the main page for this system. You will see like this table, the green row, it will be the on alarm, and the red row will be the off alarms. If there is any emergency services, we will send alert to the emergency services from here. And this is window. If the monitor sends alert to the emergency services, you will show here. It will appear here, like I send it in this alarm. I send it before to try, and it's appear here in this window. And here, this window show all users alerts window. Who used this system? It will be shown here. And this is logout system. If you log out, it will ask you about, are you sure to log out? You will see yes. Okay. This I'll finish from my side. So thank you for so much. Thank you so much. Thank you. Any questions? Thank you so much.
Sure. Do you have the static slides? Yeah. Yeah, we can present that. Using this one, memory stick, you want to plug in here? Yeah. Which one did you press?
I don't know. I just left PC and laptop.
Okay, okay. Let me see. This one.
Good morning, one and all. So I'm here today to present a website which I've made on online bookstore, and the website name is Bookberries. It's a web application wherein
That works so much better if you just flip the camera to you, not hold it. Bring the microphone to you.
So basically it's a web application wherein lots of books can be found, different kinds of books, thrillers, crime, philosophical, etc. And I have used the client-server architecture in order to implement that using the object-oriented style. And customers here can sign in or register in order to buy the online books. So this is a glimpse of how the client-server architecture works. And this is how I've implemented my client-server architecture. It can implement N clients and through procedure calls, and the clients will be connected to the server through web pages, images, logic, classes, etc. And the server will be connected to the MySQL database wherein I have stored all the data that I need to authorize the client. So this is a class diagram. I know it is quite complex, but I can make it a little easier by explaining. the client will be connected to the login page, wherein the login page will basically retrieve the client details, that is the user ID and the password. And when the client enters its user ID and the password, it will go to the user authorization page, wherein it will check for the existing user or the password condition validation through MySQL MySQL database. And the MySQL database, or basically my server, would consist of different types of books and also the user information. So basically this is the mapping of the components to its implementing class, wherein my client component is the user class, the register component is my add to the database class, the server is the user authorization file, and database connectivity is done through the UserDB database schema. The second architecture that I chose to implement was rule-based, wherein my user interface would take a query from the client. For example, if the client is searching for a particular type of book, the passage, so through a procedure call, it will search in the search engine, and through the knowledge base, it will retrieve whether that particular book is there in the knowledge base or no. Now, coming to the pros and cons of the client server architecture. The client server architecture has a centralized server which would allow the users, the access rights and resource allocation would be done by the servers. It provides you higher security because the authorized clients would only have access to the website. Cost effective, it is very cost effective because you would require very few support staff in order to maintain it. It can support n number of clients, and it is easy to repair or replace if for any kind of hazard if it occurs. For my particular website, it was very simple to implement it, and it also ensures direct communication between the client and the server. Now the cons would be overloaded servers. Overloaded servers because if there are multiple client requests, it would lead to traffic congestion. And if by any chance the centralized server fails to load or fails to start, the client request would not be processed. And since the impact of centralization would also lead to lack of robustness, so if you are downloading a file from the server and it gets abandoned, then the download would stop. Coming to the rule-based architecture, it would be very easy to modify the rules, add the rules or delete the rules. But if the disadvantage would be that if large number of rules come into picture, then the interaction between the multiple rules would become very difficult to implement. Now the reason why I selected my client server architecture was basically it supports n number of clients. The client and the servers, they hide each other's internal information. And the main reason to choose this is because the client server architecture, it replaces the file servers with the database servers. So the access user request can now be responded through relational databases on the server. And it also supports model view controller and can be implemented in the object-oriented style and supports multiple clients together and also reduces the traffic. And this is my implementation. I have used NetBeans and MySQL database in order to implement the entire project, wherein this is my home page actually. This is my contact us page wherein the customers can contact the support team for any kind of issues. These are the different types. This is a type 1 page wherein basically there are different types of books available. So this is how my execution works. This is the first page that the client will encounter, wherein he can either register or log in. So he has to do that by entering its username and password. And I have kept a few constraints for password, that is 5 to 15 characters only will be allowed. So when the user enters the username and the password, and when he clicks on the register button, we will see the entry into the database here, and we can see that XYZWA, the username, and its respective password has been entered in the database. And if the user already exists in the database, like for example the user Pooja already existed in the database, so if the username is entered as Pooja and the password is entered, and if he clicks on register, then it would show a message saying that the user already exists. Try to log in and it will redirect it back to the login page. And if you enter a password of 4 characters or greater than 15 characters, then it wouldn't accept. So again, it would redirect it to login page saying that it should be between 5 and 15 characters only. Thank you.
That's a very clear presentation. First of all, I was confused. At first you were talking about the comparison between object-oriented and client-server, but in the middle, suddenly you brought up the rule-based style, which was not explained. So are you preparing rule-based style?
Yeah, I'm still preparing. I just have to prepare 2 things. That is the search thing in order to implement my rule base, and the shopping cart thing in order to improve my website.
So actually you're going to compare the rule-based style
Yeah.
and the client server, right?
Yeah.
Okay, so that part of the materials are missing in your presentation. But overall, and I think you provided a very interesting application-oriented explanations for the pros and cons for the client server specifically. But why do you think the rule-based style or the old style are not as appropriate as the client server style? Needs to be well justified as well. Seems.
Yeah, I just wanted to mute the screen for now. Oh, yeah. Okay. Thanks. Oh yeah, I wanted to keep it muted. Yeah. Thanks.
Are we good? All right. So I'm developing a sort of social network for car enthusiasts called Garager. And basically, what it's going to do is it's going to allow car enthusiasts to archive whatever cars they have and any modifications they might have done to it. And it'll also allow them to connect with other enthusiasts and see what cars they've uploaded and comment and vote on their cars. So first architecture option was client server. So we'll basically have login, register functionality. You have the ability to add a car and retrieve a car's info, and do the same with users, as well as get a list of the cars associated with a user. And so we basically just have procedure calls from the client to the server making these calls, and then the server will return any results back to the client. So here's a kind of class diagram. It's kind of hard to do a class diagram when it's not really object-oriented, but basically these are procedures that the client can call. So you can search for certain users. You can log in with your credentials. You can register yourself as a new user with a new email address and password. You can add one of your cars. You can edit one of the cars you've uploaded, whether it's, you've changed the color, you make a modification or something like that. You can search for particular cars to see who else has a car like yours. And then on the server, we have corresponding functions to these. So when the user logs in, the server is going to check the login. When the user registers themselves, the server will do that. The server can query for users. So that could be searching, that could be editing, but basically just performing a database operation with a user. Same thing with a car. Adding a car, so that's just if you want to add your car to the database. And then we have the server connected to the database here. And so this is kind of that correspondence I was talking about. So there you go. And then the second option I had was publish subscribe. So this would kind of change the way it worked. So basically we would have more of a Twitter style system where you could actually connect with other users and receive any updates they make to their profile or their cars. And so whenever a user makes a change, they're kind of publishing a story about that to whoever follows them. So this is the level 2 diagram. Basically, you just have the subscribers here. These are the people who are following the publisher, and any events that are output by the publisher are pushed to the subscriber. And here's the class diagram. This is relatively simple. Basically, any events that happen on the publishing side get pushed to the server, and then the server pushes that to the subscribing user. And here's a mapping of that. Okay, so the pros and cons of each one. So with the client server, without the publish subscribe component, there are no rigid user relationships. And so the goal of this would be to create a kind of more open system, because on platforms like Facebook and Twitter, you often end up with groups of friends that are kind of insular and don't really have much contact with other people. And so this makes it a little more of an open platform. You can just view anyone's car anywhere, and there's no privacy to speak of, because this isn't that kind of social network. Potential con of that would be less interaction between users, because the relationships wouldn't be as tight. And then publish subscribe, there will be more engagement in those groups of people, and it delivers more information in a more pushy way. And then the cons of that would be that the community as a whole wouldn't be as engaged. There would be a lot of complexity to implementing this, as opposed to just having everything out there in the open. And there could be complexity involved with actually pushing the information to people. And then publish subscribe has the potential to discourage that kind of open nature I wanted to go for. So, as you probably guessed, I went with client server. Like I said, it better fits the nature of the application, just keeps everything open, and you can freely browse anybody's profile and cars. And so this is what I've got so far. This is the home page. This is basically proof of compilation because it's HTML and CSS. And so you've got the ability to register here or sign in. Here's the registration page. Just enter your email address and password and retype the password. It's not going to take anything else of your personal information. So that's why privacy isn't really a concern. This login page, pretty much you log in. I mean, you know how that works. And then this is a page for viewing an individual car. So you'll be able to get to this page from a user's profile, or if you search for a particular car, in this case an LS430, and you get to see the information on that car and potentially later the modifications they've made to it. So that's pretty much my demo. All right. Questions?
So I have one question. How do you address the security and privacy of users in those kind of server and publishers? I think this is one of the main issues. How to consider in comparing those two architecture styles.
Mhm.
Finally, find the most suitable one for the application. So, but in either case, this issue is very important.
Mhm.
We consider that.
Yeah. Well, part of the security thing is that we just don't take much personal information, and emails aren't going to be publicly displayed. And so we'll be doing the standard password hashing and all that. But in terms of privacy, since there's not really any personal information involved other than emails, which we won't display, I don't think security should be much of a concern.
For example, if you try to display somebody's car with the plate number, for example, in an image, or when a user tries to publish some information, but they may not know whether their privacy will be protected or their privacy will be compromised by publishing some information.
Mhm.
So this is something you might want to consider in your design
Mhm.
and the selection, and how to prevent users actually publish something which may compromise their privacy.
Yeah. I was thinking either that angle, or I would basically just have a privacy disclaimer that the user is allowed to upload whatever they want. If they want to upload their plate number, that's their choice, but the site won't take any responsibility if they choose to upload their license plate number. So either that, or I could find an algorithm to blur license plates or something, but I was thinking I could probably leave that up to the user, because generally having license plates online is not a major issue. But there are several approaches I could take to that issue.
Yeah, so yeah, it would be good if we could consider that, consider those non-functional properties
Mhm.
in the comparison. But overall, it's a very neat presentation. Thank you. But why didn't you do a live demo?
Live demo, because some functions of it aren't working yet, and it's mostly a static site, so the screenshots basically serve the purpose. So yeah, all right, thank you.
Since we still have a few minutes, I would like to give you a further explanation about the last ADL that we have covered in the previous classes on the Zato. I would like to give you a few more examples. the examples I would like to illustrate are for you to understand a little bit more about the Zado, how the Zado can be used to extend the existing XML infrastructure, extend XML construct based on the XML schemas. So first of all, let me give you a generic definitions of components. And remember that last time we have illustrated an example using Zado to define a generic component in our architecture diagrams, right? In our architectures. So basically, we surround the definitions with the XML tags. And if you still remember our example, this is another more simplified or more concise demonstration of the component definitions. So here, we would like to define a generic component type, which belongs to a complex type. It's just like a complex object, complex class we are going to define. And here, each component should contain a description, and then at least one interface. So basically, the number of interfaces can be 0 or unbounded. Okay, so we can have as many interfaces as you want. And then we would like to define the type of the components. And so basically, we would like to assign one type of components, at most one type of components or not. And then each component should have an ID, which is unique to identify the component. And then from on top of the generic components, if we would like to define the data store components in our Lunar Lander application, so the next component type we would like to define is a database. So if we would like to design the data store components using the database, right? You can choose to use a file server or something like transient memory space to store the data in the data store component. But here, we would like to use database to store the attribute in our data store components. So here, how we can define the database component. So this is another definitions of database components. And this is first an abstract components, which is true. And then there are 3 types of databases, 2 types of databases that are defined here: relational database and file databases. So in defining the database as specific type of database, we would like to differentiate the specifications under each of them. For example, in the relational database, we have to define what are the database tables, what are the names of the database tables, and how many replicas you're going to implement for each database table, right? For the reliability concerns. But can you stop noting, because it may interfere with the quality of the lecture for the remote students. So the file database has the file name on that. The file database has at least one file name, which is in type string. So, and we need to have a host name to indicate where to host that file, right? So the host name is also defined by a string. And we can define 0 or 1 host name for the file database. So since we have defined our database, generic database, as well as an abstract database type. So we have defined our abstract database type and abstract component type. So now we can integrate the definitions to evolve our database component, which is a combination of the prior 2 definitions. So database component is considered extended directly from the component definitions, abstract component definitions. So we have to follow the definition to provide the descriptions, which might be optional, and we could provide 0 or unbounded number of interfaces, and the type. So here, we would like to define the type of the component as database. So which has been defined as an abstract database type here. And the name of the components is database as well. So in this way, we can declare database components, which is named as database, and which is extended from our abstract component definitions, as well as with all the attributes of the abstract data type database here. So this is how we explain, how we specify and evolve the current XML schema, the current XML metadata infrastructure and construct to extend, to define and introduce the new kind of infrastructures and constructs in our architectures. And then after we have defined the database component, then we can go back to our final instantiation of the database components. So here, we are going to instantiate our newly defined database component into an instance called data store. So in our Lunar Lander applications, we have specifically have a data store instance, which is declared, which is an instance underneath the database components. And it has a description of data store. And it has a unique interface. It has a unique interface ID, which is get values from the data store and store values from the data store. And the direction of each interface is inward. And we also have some descriptions underneath both interfaces. And then we are going to define this data store components as a relational database. So the type of the data store which is going to be designed is specifically a relational database with a table named as Lander data and with the number of replicas as 1. So there is only one database table with 1 replicas. So we're going to design 2 duplicate Lander data relational database tables underneath this data store components. So this is how we instantiate the database components that was just defined and evolved from our abstract components definition as well as the abstract database component. So this is how Zato did in instantiating, declaring, evolving the current XML metadata. So is there any questions? So the homework 3 asks you to use the C2 saddle to define your own architecture based on the C4 systems that you have designed in homework 2. Is there any questions you would like to discuss? If not, I'll call for today. And next time, if you would like to come to present, especially for those who present first, please make sure that you have some backup plans to deliver your presentation through our classroom computer, because if you need an HDMI slot or Mac adapter, it may not be compatible with our system here. So it may affect your final presentation quality. Okay, so I'll call for today. I'll see you on Wednesday. So next time we will have 4 presentations. Please be prepared.